So welcome back to another video of AJ classes. So today's question is, let R plus be the set of all positive real numbers. Define the operation of addition and scalar multiplication as follows: that u plus v is given that u into v for all u v belongs to R, and alpha u is equal to u to the power alpha for all u belongs to R fold and real scalar alpha. So what is given here? It is defining if you add this u and v to vector spaces, the result will be u into v. So first of all, to prove this, so how will you do the proof? First one is, given that R plus, what is R plus? R plus is the set of all positive real numbers, all positive real numbers. So given that R plus is the set of all positive real numbers, and addition and scalar multiplication, in R plus are defined as follows. So हमारा R प्लस का क्या दिया है, उसका एडिशन एंड प्रॉपर्टी क्या दिया है, u प्लस v इफ यू आर टू वेक्टर स्पेसेस u एंड v मीन्स इफ हम आर करेंगे u और v दो वेक्टर स्पेसेस को, तो उनका रिजल्ट क्या आएगा, u इंटू v. इट इज गिवन एंड वी कैन चेंज दिस, एंड दिस इज फॉर ऑल u एंड v बिलोंग्स टू R प्लस. मीन्स हर एक u और v जो R प्लस को बिलोंग करता है उसका ऑपरेशन कैसे होगा, अगर आप दोनों का ऐड करोगे तो उनका मल्टीप्लाई होगा, एंड इट इज़ गिवन कंडीशंस. And if you multiply scalar multiple with a vector space u, then or a set u, then that will convert to that power u to the power alpha for all u belongs to R plus, and alpha is a real scalar. So these are the given conditions what is given in the question. So now you have to prove that, or we have to prove that, to prove that, what we have to prove that R plus is a real vector space, that R plus is a real vector space. That is, we have to prove that for all, u v w belongs to R plus, and alpha comma beta are scalar, alpha and beta is scalar. We have to prove that. The first point is, we have to prove, what is the first point, that u plus v belongs to R plus, that is the closure property, that u plus v is equal to v plus u. The third one is that u plus v plus w is equal to u plus v plus w. The fourth one is, there exists an element 1 in R plus such that u plus 1 is equal to 1 plus u is equal to u for all u belongs to R plus. Or this 1 is not fixed, this can be variable, means there is a number present, if you add that number with that number you will get the same number. And for number 5, that for every u in R plus, there exists 1 by u in R plus such that u plus 1 by u is equal to 1 by u plus u is equal to 1. So these are the first five postulates which you have to prove. We have to here prove the 6 postulates, and if all the 10 postulates are satisfied, then this will be called as a vector space. Number 6 is the scalar multiplication, that alpha u belongs to R plus, the closure property of multiplication. The 7 is that alpha plus beta into u will belongs to or is equal to alpha u plus beta u. Number 8, that alpha into u plus v is equal to alpha u plus alpha v. Number 9 is that alpha into beta u is equal to alpha beta into u, and the last is that 1 into u is equal to u. We have to remember all these 10 properties that a vector space satisfies. The vector space satisfies all these 10 properties, and if we prove that this is applicable in this given conditions, then this R plus will be a vector space. So we have the first case is, the first one is that u plus v, that is also equal to u into v. The given condition, the addition in the given condition, u plus v is equal to u into v, and we know that both u and v are given that real positive real, and if you multiply to positive real numbers, then you will get a positive real number, and this belongs to R plus, that u plus v belongs to R plus. We have proved the first one. The second one is that u plus v, if you call the second one is, we have to prove that u plus v is equal to v plus u. So that u plus v is equal to, how you can write that, u into v, and u into v we can write this as v into u, and we can convert this as v plus u, because these are the given condition. The sum is expressed as u into v. The third one, what we have to calculate, the associative property, that u plus v plus w. So you have to put solve here the associative, that u plus v plus w. So this will be u plus v into w, or from here you can write down this is also plus u plus, and this will be u into v into w, or you can write down this as u into v into w, and you can write down this u plus v into w, and convert this as u plus v plus w. So our third property, or associative property, is also satisfied. Then the next, number 4. The number 4 is, as 1 belongs to R plus, then u plus 1 is equal to 1 plus, that is u into 1 is equal to u, and there is just 1 plus u is equal to 1 into u is equal to u. The same we are getting the u, and this is the proof of the fourth point. The 5 is let, the 5 one is let u belongs to R plus. If u belongs to R plus, this implies that 1 by u, that will also belongs to R plus, and if u belongs R plus, then this plus u plus 1 by u. The property is that u into 1 by u, you are getting here 1, or 1 by u plus u is equal to 1 by u into u is equal to 1. Here however it is multiplying, this is the given condition. If the two vector space are added, that u plus v, here the given condition u plus v is equal to u into v. By applying this, we will get that 1 by u plus u is equal to 1 by u into u is equal to 1. So these are the fifth. Then the sixth one is that, you know that alpha into u, this will convert to the u to the power alpha, and positive real number to the power positive scalar, this will also, that belongs to the R plus. So then therefore the next, number 7 is that alpha plus beta into u, you will get here that that u to the power alpha plus beta, or this is equal to u to the power alpha into u to the power beta. We know that u to the power alpha, we always know this is alpha u, and into this will be beta u. We know that further the multiplication will be converted into addition, that alpha u plus beta u. The seventh property is also satisfied. The number 8 property is that alpha into u plus v is equal to, u plus v, we will convert this as alpha into u into v, and then convert this into u into v whole to the power alpha is multiplied, that will convert into power, and this will be is equal to u to the power alpha into v to the power alpha, and then it further conversion to u to the power alpha है. हमारा गिवन कंडीशन में क्या है, अगर पावर होगा, अगर मल्टीप्लाई होगा तो पावर होगा, तो पावर है तो मल्टीप्लाई हो जाएगा, तो अल्फा यू इंटू अल्फा वी, एंड अगर मल्टीप्लाई है तो हमारा सम भी हो जाएगा अल्फा यू प्लस अल्फा वी. देन नंबर 9, that alpha into beta u is equal to alpha u to the power beta is equal to u to the power beta whole to the power alpha is equal to u to the power beta alpha, or you can write down this as beta alpha into u, or alpha beta into u. Then number 10 is that one that 1 into u is equal to u to the power 1 is equal to u, and hence it's proved all the 10 properties are satisfied here. So hence you can write down that R plus is a real vector space. So this is the proof of this question, and if you like the lecture then like the video and subscribe the channel.